Hey geometry students, this is section 2.6 part 2 of proof statements about segments and angles. So what I'm going to do is skip through until the portion that we left off. Okay, I think this is it. So in this, what I have is we're going to start out with say whether each statement can be determined from the diagram or cannot be determined from the diagram that I have below. Okay, it says B, C, D are collinear. So if we look at this diagram, we see that B, C, and D do not have a line going through it. So they cannot be assumed collinear. So no. And then the next one, it says segment AC is perpendicular to BE. And let's see, that is this line right here and then this line right here. Okay, since we do not have an angle marking such as this right here, we cannot assume that they are perpendicular to each other. So this is a no also. And let's see, next part says angle BFC and angle CFE. Angle, let's see, BFC and CFE. These are a linear pair. Yes, that is true. Remember, this lies on a line. This one is lying on the line too. They are these are adjacent angles lying on the same line. So that meets the requirements for a linear pair. And then angle CFE, this one right here, and BFA, this right here, are vertical angles. Yes, that can be assumed because that meets the definition of vertical angles. Okay, so let's get started with our proofs in this section. Okay, it says angle 3 in our given information up here, angle 3 and angle 2 are complementary, and measurement of angle 1 plus the measurement of angle 2 equals 90 degrees. Okay, so by definition of complementary, we should know that angle 1 and angle 2 will add up to be a 90-degree angle if that whole angle there is 90 degrees, which it is. And this is what we have to prove. Angle 3 is congruent to angle 1. Alright, so let's get started here. Let's go ahead and state our given information. So angle 3 and angle 2 are complementary. Okay, so that is given. You can also go ahead and state, you don't have to state this in a separate one, but it's stated on your paper, your handout like this. So let's go ahead and follow along with your handout. The angle 1 plus angle 2 is equal to 90 degrees. Like I said, we didn't have to state this all in another whole statement. We could have just stated it with the first part and said given. But these are both given, so let's write those down. Okay. What I'm going to state next is that the measurement of angle 3 plus the measurement of angle 2 is equal to 90 degrees. Okay, and that is because of this statement right here. Where's my highlighter? Right here. Angle 3 and angle 2 are complementary. That translates to they add up to 90 degrees. So by definition of complementary angles is what we use there. I'm just going to abbreviate it as comp angles. Okay, 4. Well, we know this statement right here to be true, that angle 1 plus the measurement of angle 2 is equal to the measurement of angle 3 plus the measurement of angle 2. Okay, and that we know to be true because this right here, they both equal 90 degrees. So we can substitute this in for this, or the other way around. So using the substitution property is what we just used for this fourth statement. Let's go on to statement 5. We can say that the measurement of angle 1 is equal to the measurement of angle 3. And that is because we subtracted a measurement of angle 2 from both sides. And that canceled each other out. So subtraction property is what is being used on 5. And then 6, we know we can state that angle 1 is congruent to angle 3 now. Because we know their measurements are equal, then they are congruent. That's what the definition of congruent means. Definition of congruent angles. Okay, and there we go. We are done. Let's go on to the next one. Okay, given the measurement of angle 4 is equal to 120, and we know angle 2 is congruent to angle 5, and angle 4 is congruent to angle 5, we are going to prove that the measurement of angle 2 is equal to 120. Okay, so let's just go ahead and start stating the given information. Measurement of angle 4 is, well, let's just state part of the given information. The most important part right now is that angle 2 is congruent to angle 5, and angle 4 is congruent to angle 5. Okay, well, we almost have the transitive property here. See that? We have angle 5 here, angle 5 here. We could go ahead and state that we know if angle 4 is congruent to angle 5, then angle 5 is congruent to angle 4 by the symmetric property. Okay, so we're going to state our given information a little bit over again. We know angle 2 is congruent to angle 5, and angle 5 is congruent to angle 4. Just using the substitution property. For this piece right here, I'm substituting this in here to make up this statement. Alright, let's go to 4. Well, we do have the transitive property in this last statement, in statement 3. So we can go ahead and say angle 2 is congruent to angle 4 using the transitive property. Now, angle 5, well, not angle 5, sorry, step 5, let's go ahead and state that we know that the measurement of angle 2 is equal to the measurement of angle 4 using the definition of congruent angles. So let's go ahead and substitute in. Actually, let's state this up here, this portion of the given information that we haven't stated yet, because we need to state it in our proof somewhere. So we know that the measurement of angle 4 is equal to 120. That's given. So let's substitute in that 120 in for measurement of angle 4 to get this statement here. Measurement angle 2 is equal to 120 degrees. And that's what we were wanting to prove. And we use this substitution property for that last one. Whoops. Let's put an ST. And there, we are done. We have arrived at the statement that we wanted to prove. We probably could have, eventually, when we get a little bit better at our proofs and we can see statements more clearly, we're not going to have to exactly state every single little detail that we just did in this proof here. Okay, let's go on to the next one. Okay, so here we are asked to solve for x and explain each step. So our given information here is that segment KP is congruent to segment PN, and we know that KP is equal to 18, and we also know in this diagram right here that PN is equal to 7x minus 10. So we're going to be using that also in our proof to solve for x. Okay, let's go ahead, start with our first statement, which is our given information. KP is congruent to PN. And KP is equal to 18. And I'm going to go ahead and state that PN is equal to 7x minus 10. All of that is our given information. Okay. Step 2, I'm going to go ahead and say Since KP is congruent to PN, those two segments, we can say KP is equal to PN, which is using definition of congruent segments. Okay. Step 3. Since we know what KP and PN are equal to, let's substitute them in, all in this one step. Since we know this KP is equal to 18, plug it in, and PN is equal to this, we're going to plug it in. So 18 is equal to 7x minus 10. When we plug things in for each other, that's the substitution property. Okay, step 4. Let's add 10 to both sides. So now at this point we are solving for x. So isolate that x. So add 10. We get 28 is equal to 7x. So in that step, we used the addition property of equality. And then the last step, because at this step we are going to divide both sides by 7, we get x by itself. We get x is equal to 4, and we have solved for x. And we did that last step by using the division property. Okay. Alright, so I'm going to do actually one more proof, which is not on your handout, but please draw it in as I do this, okay? It's on this next page. Okay, it says, given ray BD is an angle bisector of angle ABC. We're going to solve for x. Alright, so let's do our statements and reasons columns and write this out. Okay, so first thing that we are going to do is write the given information. So ray BD is an angle bisector of angle ABC. Okay, so that's given. Okay, just think about what this actually means. If ray BD is an angle bisector of ABC, then we should know this, that this angle is congruent to this angle. So state that in your next statement. Angle ABD is congruent to angle DBC. So what we used to come up with that angle ABD is congruent to B or DBC is the definition of angle bisector. Okay, hope that makes sense to everybody. If not, please let me know and I'll help you more in class. Okay, now to go from congruent statement to a equal statement, I'm going to say that the measurement of angle ABD, ABD is equal to the measurement of angle DBC. And remember, going from congruence to equal or equal to congruence, that is using the definition of congruent, and this time angles. Okay, 4. What we are going to use here is the information that you see in the diagram. The measurement of ABD is this right here, 5x. And the measurement of DBC is this right here. Okay, because we're wanting to solve for x. Let's get to solving for x. Okay, so substitute in 5x, and that's equal to 2x plus 18. That substitution property. And then now let's solve for x. So what I'm going to do is subtract 2x from both sides, and I get 3x is equal to 18. So that was the subtraction property. Now the next statement is our last one, because after this we've solved for x. Divide both sides by 3, we get x equals 6. So we use the division property. And we are done. So we solved for x using that information that we had from the beginning, that ray BD is an angle bisector, and we used our diagram to figure out what x is equal to. That's all I have for you in this section. We are done with it. I'll see you guys all in class.